This is for the 408 quiz on February 13th, so Wednesday, which I am off on that day. So nothing special for you guys, just I'm off that day. So here's what your 408 quiz is going to look like. Your question one, we're working more on our transformations. So your question one is going to look at identifying a transformation. Question two is going to ask about rotation. I'm not identifying it, but just asking what could be true about rotations. Question three is going to talk about what can be transformed. Question four, which translation vectors could have been used for the pair of figures? We'll look at what a vector is today. And then question five, you'll be looking at rotation points, the center of rotation and what is possible with those centers of rotation. Let's continue on. There is no new vocabulary with 408. It's a continuation of 407. So it's pretty much the same words, just repeating them again and going a little bit more specifically into them. So remember, our four types of transformations were flip, turn, slide, and shrink. And flip is what you might commonly call a reflection. And that's this orange triangle right down here. You can see that it was flipped over that line or a reflection. A turn is a rotation. So you can see that the blue one up here was rotated. And then our, let's see, next one on the list is a slide, so that's a translation. And so doesn't change the orientation, size, anything to do with the shape, just its location. So that would be your translation down there with the purple square. And then our last one would be a dilation, which can be a shrink or an expansion. It's either, so that would be the green circle. In that we can see it got bigger, so that would be an expansion on that one. So it could be a shrink or an expansion. So we're going to practice actual rules on how we reflect things. So with reflection, you always have a line that you're reflecting over. Think of that as the actual mirror. If you were looking in the mirror, what this triangle, if they were looking in the mirror, what they would see in the mirror. So there is actually a rule for how to do this. It's not just willy-nilly. So if you are reflecting over the y-axis, so y-axis is right here, and golly gee, that was pretty darn straight. A little bit of mishap right there, but pretty darn straight. So the rule is, and this is easiest to do with points. Obviously, you can reflect a point, you can reflect shapes, you can reflect lines. Any of those can be reflected over. So here's the rule down here. It's written in coordinate points. So what's easiest when you're doing this is to go ahead and with a shape, just go ahead and label the vertices. So for example, let's see, I'm going to call this one A up here. And I don't think that green is great. So I'm going to change over to, let's see if red's a little bit better. Perfect. So we're going to call that A. And its coordinate is, let's see, is -4, 8. And then I'm going to go ahead and call this one B, and its coordinate is -6, 1. And this one is going to be C, and its coordinate is -2, 1. So it's easiest if you start off with writing the coordinates for all the vertices. And then the rule is to take the coordinate pair. I'm going to start with A, -4, 8. And the place that it ends up, you change the sign of the X. So it was -4. It's going to become 4. So it was -4. So basically you just change the sign. If it's 4, it becomes -4. If it's 7, it becomes -7. If it's -12, it would become 12. So change the sign. And then the y value stays the same. Just y right there. So that was 8. So the new location of A, or where we're going to put A prime, would be at 4, 8, which is right here. So I'm going to go ahead and mark that and label that A prime. And then same thing for B. I'm going to do B next. So its initial point was -6, 1. So following the rule, again, my new x coordinate is the old x coordinate, just changed the sign. So it was -6, it becomes 6, and my y coordinate is 1. So B prime is going to be located at 6, 1. And that would be right here. I'm going to go ahead and label that B prime. And then last one, C. C's initial coordinate is at -2, 1. So again, I take the x value and I flip the sign, so it becomes 2. Y value stays the same. And so the new C, C prime, will be at 2, 1, which is right there. Go ahead and label that. Okay, and then I'm going to grab my line tool. Don't have a line tool in this program. Whoop. So we're going to freehand this. Eek, eek. There you go. So I have reflected this triangle over the y-axis. This rule right here is very important in reflecting over the y-axis. So make sure you have that rule written down there. So we've reflected that triangle over the y-axis. Now, of course, there's also the x-axis. So same idea, same triangle actually. So if we go ahead and remind ourselves, this was A, and that was -4, 8. And this was B down here, and that was -6, 1. And this is C down here, and that's -2, 1. So there's our 3 vertices or corners for the triangle. So the rule for reflecting over the x-axis is really similar. If you notice in the previous one, your y value stayed the same. For this one, your x value stays the same. So I'm going to show you with A. Our initial one was -4, 8. So that becomes our x value stays the same as the initial x value. And then our y value changes signs. So what was 8 turns into -8. So our A prime would be at -4, -8, which would be right there. And let me go ahead and label that. That's A prime. And then our B was initially at -6, 1. So again, our x value stays the same. That's -6. Okay, here's the rule right here. And our y becomes negative, or opposite sign of whatever it was. So our new B is at -6, -1, which is right. Oh, I was close right there. Whoops. Let's see. And so let me go ahead and label that B prime. There we go. Didn't mean that. I didn't need the parentheses there. Oh well. But if I hit erase, it'll erase everything on the slide. So that is bad. So we're just gonna leave that there. And then our C was -2, 1. So again, our x value stays the same, and our y value changes signs. So our new C, or our C prime, would be at -2, -1, which is right there. And I'm going to label that C prime. And then I'm going to go ahead and connect those dots. And here I have the same triangle. It's just flipped over the x-axis. Again, this rule right here, the rule for how to reflect over the x-axis, is very important. One thing to notice, and if you didn't notice on the previous one, I'll show you on this, the distance between the point and your reflection line stays the same. So for example, B right here is 1 unit away from the x-axis, and B prime is 1 unit away from the x-axis. And then if you look at C, same thing, C, C prime. They're both 1 unit away from the x-axis. And then your A is 8, 1, 2, 3, 4, 5, 6, 7, 8 units away. Sorry, that was A prime. And A is 1, 2, 3, 4, 5, 6, 7, 8 units away from the x-axis. So the distance from the point to the reflection line is the same as where the image, remember the pre-image and the image, it's the same distance as the image. Okay, they're going to be the same distance away from the reflection line. And it was the same for the y-axis one. X-axis, what I'm showing you right now, but it's going to be the same for the y-axis that we already did. Okay, so translation has vectors. So we're flipping them from our reflections over to translations. So translations, remember, are slide. It's just moving it. It's like it's a little piece of paper on your desk and you're just pushing it one direction. A vector would just be an arrow description of where the object moved to. Now the arrow usually is a combination. It isn't just like left or right or up or down. For example, if this is my object and, sorry, my pre-image, and this is my image down here, then your vector, your description of where it went is this. Just describe if you were sliding it from pre-image to image, what direction did you move the object? Another one, if I had, this is my pre-image and this is my image, and so my vector, my translation vector would just be up in that case. So the vector is just an idea of what direction did it move. Did it go down, left, right, combination? Did it go up and to the right? Just draw an arrow going from the pre to the image. So here's an example, pre-image. So where we start, this is our end, our image. So to draw a vector for this one, I would go down and to the left. With these drawing of the vectors, not terribly concerned about, oh, well, it should have been an angle of, you know, it doesn't look like it's 45 degrees. I don't think right now you really need to worry about the angles so much as just the general idea of you move down and to the left for this one. We can give actual rules for translations, just like with the reflections, you had that, you know, x comma negative y, or negative x comma y, depending on which one you were reflecting over. For translations, you can have actual rules for them as well. So I'm going to draw you a very simple shape up here. And let's go with let's just do a black shape up here. So I'm going to keep it simple and just have a rectangle right here. Sorry, we'll make it a square. There you go. So we got a square right there. And so the rule for translation is going to be these values right here, the plus k, will tell you if you went down, up, left, and right. So I'll give you an example here. If my rule was x plus 1, let's see, that should be a comma there. Oh no, if I erase, is it gonna, oh, whoosh, managed to erase just it. Okay, and then let's call it just y. Let's do a simple one. I would take each of the coordinates of the 4 vertices and I would add just a 1 to their x. So for example, this one right here, its x coordinate is 2. So I'm going to add 1 to that, which would be 3, and its y coordinate would stay the same. So its new point is right there. And then for the next one over, this one is at, ooh, maybe I should do that in separate color, is at 4, 3. So I'm adding 1 to the x value, whoop, and leaving the y value the same. Notice it's just moving, in this case, over to the right 1. Any number in the x will tell you left or right. So if it's a positive, you're moving to the right. If it's a negative, you're moving to the left. So this number here will tell you left or right, and by how much. If there's no number in the x, if it's just x, then that tells you it's not moving left or right at all. It's purely vertical motion up and down. I'll show you a separate one, so let me get rid of this. Let's try another one. And okay, so for example, let's draw a simple square. We'll put it right here. And let's say that our rule for translation is x. I'm trying to keep these very simple. Let's say y minus 1. So if you notice, the x value here is the same as whatever you started with. So it won't be moving left or right. But there is this minus 1 in the y column, in the y section. So I'm going to switch to purple. Hopefully that'll help you see where the new points are. So my initial first vertice is at 1, negative 2. So my rule says keep the x the same, 1, subtract 1 from the y. Negative 2 minus 1 is negative 3. So this top left vertex, I should say, one single one, is at 1, negative 3. Boom. Okay, next one, I don't think that purple is working great on that background. Let's see if white works better. So my top right vertex, better, is at 3, negative 2. So my rule says leave the x alone and then subtract 1 from the y. So negative 2 minus 1 is negative 3. Okay, so this one is at 3, negative 3, which would be right there. And then I could continue on with the other two vertices. So the bottom left vertex is at 1, negative 4. So my rule says leave the x the same and subtract 1 from the y, and that's negative 5. Negative 4 minus 1 is negative 5. Boom. And once you have like the first 2 points, you probably can just figure out where the fourth point is. The third and the fourth, but there you go. So it's a slide, and I slid it down 1. So you can tell when I have a negative in the y section, that's going to move you down. And if it was a positive there, it would move you up. So let's do a quick combination where we're moving both vertically and horizontally. Let's get rid of all this. There you go. Okay, and so let's draw ourselves a new rectangle. We'll keep the squares. And let's put it up here in our quadrant 1 that we're all happy with. No negatives, there you go. And so let's say its rule for translation is x comma y turns into x plus 2, y plus 1. So I'm going to start with the top left corner. Top left corner is 2, 3. Sorry, that 2 is not great. 2, 3. And so I'd add 2 to the x. 2 plus 2 is 4. And I'd add 1 to the y, and that's 4. So that one is now going to be at 4, 4. So I'm going to go over to 4, 4. Boom. Okay, continuing on, I'm going to go to the top right vertex, and that one is at 4, 3. So again, my rule says add 2 to the x, that's 6. Add 1 to the y, 3 plus 1 is 4. So the new vertex, top right vertex, would be at 6, 4. Boom. And continuing on, bottom left one is at 2, 1. And it doesn't matter what order I'm going in. We're trained to go left to right, top to bottom. So that's what I did. So 2, 1. Again, I add 2 to the x. That would be 4. Add 1 to the y. That would be 2. So that bottom left vertex is now at 4, 2. Boom. And chances are you can just visually see where the next one is, but I'll go ahead and write the rule for you up here. It is at 4, 1 to begin with. So I'm adding 2 to the x, 1 to the y. So its new location would be at 6, 2, which is right there. So my vector, if I were to draw in a vector, would be up and to the right. I moved it up and to the right. And I can tell that it's moving to the right because it was a plus 2. I added in the x section, so that means to the right. And then I can tell that it went up because I added in the y as well. So both of those together, I could have just told myself, okay, it goes up and to the right. All right, let's look at rotation. So rotation, this is an image that we saw Tuesday in class. And we saw that this was the center of rotation. One thing about rotations, one, they should be of equal size. They should be congruent. So AB and A prime B prime are the same length as each other. AD and A prime D prime are the same length as each other. And we decided that this was the center of rotation. We rotated around A, this being the pre-image right here, and this is the image. So this was starter, and this was our end. So we rotated around A. Notice that A and A prime ended up on top of each other. So if you rotate around a vertex, you're going to end up with that vertex always being on top of each other. And initially, when you start the rotation, there will be a whole bunch of overlap. But once you get past a certain point, you're just going to overlap in that one single place. So we started here and they started rotating this way. And initially, you would have had some overlap. But once you passed like your A prime, D prime, whoop, it was right here and it kept rotating up. Then you got down to just that one single point at which the two were overlapping. And then if you continue rotating around, it's going to keep with just that one point again until your A prime, B prime, this line right here, is going to keep rotating around, and then it's going to eventually hit AD, and then there will be overlap again. So really the only time that you get one point of overlap is if you use a vertex. It doesn't mean it's always one, but it's the only way you're guaranteed to have one at some point. Let's see. So in these, another thing that's helpful to identify the center of rotation is to look at distances. So let's assume that the solid is our pre. So this is our pre, and this is our image. Okay, so this is where we started our ST, and this is where we rotated to. Okay, the dotted line up there, that's the rotated to. If you were to measure the distance from each point, and this one's obvious, we rotated around T. The distance from the points should be the same. So if I measure R to T, that should be the same as R prime to T. If I measure S to T, that should be the distance as S prime to T. Those distances should remain the same. Now this one's clear because you can tell, you can see, this one's a little more obvious that the center of rotation is the T right there. But let's move down to this bottom one, a little bit trickier. If you were to look at different options as to where you might have rotated around, and it's a square, but they help you figure out what the orientation is by putting that little object in the corner there. Okay, so that should help you out. For example, if it is L, I'll go ahead and like the center of rotation is L. So if I were to measure from this corner that's closest to the shape to L, direct line, and then measure from this corner to the L, that should be the same length. If I were to measure the corner opposite from the shape to the L, and let me change a color for you there so we can do this in blue, and whoop, and measure to L, then I should have the same length as that corner to L. And visually they do look the same. And let's see if I was going to do this corner right here, a little tricky, to this one. There's only, you know, 2 other corners available, and it's obvious it's not this corner labeled Y because that's just way too short. So it's got to be this one across. Whoop. That's the same length. So again, if you're not sure on what the center of rotation is, pick a vertex on the shape, measure from that vertex to what you think is the center of rotation, and then measure the same vertex on the image, and if it's the same distance, then that is the correct center of rotation. Let's look at this one up here in the right to kind of practice that. So you can kind of tell from just the shape itself. If this is Z, then hopefully you can tell that this one is Z prime. And then if this is, let's go with L, then you can tell that this one must be L prime. Okay, just to label the other ones. So let's say I'm thinking to myself that they rotated around the N, just randomly, okay? I would measure from N to L, there's N to L in purple, and then I would go N to L prime, and I would tell myself those do not look like the same distance. Okay, so again, I'm saying I think it might be N. I think N is where they rotated. So I went from N to L and N to L prime. If it is the center of rotation, those should be equal. I look at that and I am saying, nuh-uh. These pictures should be accurate, otherwise it would be very hard to tell center of rotation. So you should be able to trust distance on these, otherwise it would be virtually impossible to do these. I could do the same thing with Z. Let's say once again, I'm like, I think N is the center of rotation. I would measure the distance from N to Z, and then I would measure the distance from N to Z prime. And once again, I'd say, oh no, N to Z prime looks far shorter than N to Z. So I'm going to tell myself it's not N. So the other option there is Q, which let's try the same thing. I'm going to go from Q to Z and Q to Z prime. Looks pretty close. Let's try it. I'll switch to green. Q to L. Sorry, the line didn't go straight. And Q to L prime. Hey, that looks pretty good. We can do another one that's a lot easier. For example, here's the N prime. Ooh, let's see. Q to N, Q to N prime. That looks pretty good. So you can use the distances to help you identify the center of rotation if it's not obvious. I know the top left one's pretty like, oh, they're rotating around T, sorry. Another trick, and I know I don't have a camera right now, if you are just absolutely positively not sure, grab a piece of paper, sketch the shape. Don't grab a piece of paper that is the size of the shape. You want to get one, so like you would get a full rectangle of paper for this one. You would draw on it RST and then grab a pen and hold it firm on top of what you think is the center of rotation, and then just rotate the paper, and that'll show you where it would end up, and just try to make it match the image that you're given. So you kind of have to, with one hand, hold firm with a pen on the point, and then with the other hand, rotate the paper. The reason you want it to be bigger is because obviously if you're rotating outside the shape, So if you were rotating like over here, you would need to be able to put your pen on that spot on the piece of paper and rotate around it. All right, so that's identifying center of rotation. There are rules for how we write the rotation for specific points. It's very common to rotate around the origin because it's the origin. That's why. And so these are the rules for rotating around the origin. We only really do like 90 degrees and 180 because once you get 90 and 180, you can kind of combine those to get 270. And we don't do, you know, rotate around 87 degrees. Like we just don't do that. You're just going to stick to 90 and 180. Okay, so here's the rule right here, and I'll show you with the 3 vertices. So this one is 2, 2, and this one is 5, 2, and this one up here, we'll call it 3.5, 6. Okay, and let's go ahead and I'll call this A, B, and C. Why A, B, and C? First 3 of the alphabet, who cares? All right, and so I'm going to do this we'll do it in white. So the rule for 90-degree rotation, and this is counterclockwise. So you're going to be going whoop this direction. Okay. So the rule for this one is a little backwards. So let's do A first. If you start in 3.56, okay, you're going to take the Y and it replaces the X, and then change the sign. So it was 6 for the Y, I'd make it -6, and it becomes my new X. And then my previous X value becomes my Y. A little bit crazy there. Okay, so A is now going to be A prime, and it'll be located at -6, 3.5, which is right there. And I'll label that A prime. And then your B was originally at 2, 2. So again, your Y value comes forward to be your X value, negative. And then your X value gets switched to your Y value. So B prime will be at -2, 2. So B prime's right here. And C was at 5, 2. So C prime will be at -2, 5. So you're flip-flopping them and you're changing the Y sign. So C will be at -2, 5, which is right there. That's your C prime. Whoop, whoop, whoop. So you can imagine that I drew this on a piece of graph paper. I put my pen right there, and then I went whoop, and I rotated it 90 degrees. Now I'll show you the 180. I gotta erase this work just for the sake of, I can try to leave it up there. Eek. So we're gonna grab a highlighter, and this is all for the 90 degrees. Eek. There you go. That was the 90-degree stuff. So for 180, I'm going to use the initial point, the initial triangle, okay? So for 180, yeah, it'll work. You just leave the X and the Y in the same place. You just change their signs. So A was at 3.56. That's going to become -3.5, comma, -6. So our A prime would be at -3.5, -6. Boom, right there. There's our A prime. And then our B, it was 2, 2. It's going to become -2, -2. So our B prime would be right there. And our C, it was 5, 2. And it's going to become -5, -2, whoop, which is right there. And watch out, watch out, watch out, C prime. So again, it's like I drew triangle ABC, then I put my pen down on the origin and I rotated it 180 degrees. And that's where I ended up. So again, off of this slide, most important things, getting those two rules down. Reminder, isometric, we didn't do any dilations today. That's in a few lessons. We just stuck to our 3, and those are all isometric, meaning that they preserve distances. So your objects ended up with the same side lengths as well as the same overall size. All right, thanks for watching, and your password for the 13th of February is Tessa. Have a great day.